Hello everyone. So now we're discussing about the magnetic effects of current. Magnetic effects of current. So every current carrying wire is having the magnetic field around it. So every current carrying wire having the magnetic field around it. Suppose this is the current carrying wire. So here I am connecting the wire to the battery. So every current carrying wire is having the magnetic field. So here the current is flowing. So the electric charges are moving in this circuit. So the charge moving with a constant velocity produces the both electric and magnetic field. So the charge is moving with a constant velocity. So it produces the both electric and magnetic field. The charge is flowing in this way. So it produces the both electric and magnetic fields. Suppose the charge at rest. The charge is not moving. Suppose the charge is not moving. So it is at rest position means it produces only electric field. So it produces only electric field. So the two here I am taking two charges, two positive charges. Here the two positive charges are at rest means it produces only electric field only. So whenever the charge moving with a constant velocity, the charge moving with a constant velocity only produces the both electric and magnetic field. If the charge is at rest means it produces only electric field. The source of the magnetism is a moving charge. So moving charge ఉంటేనే magnetic field produce అవుతుంది. The source of the magnetism is the moving charge. So whenever the charge is moving with a constant velocity, so it produces both electric and magnetic field. So every current carrying wire is having the magnetic field. So next, suppose here I am taking this is the, so let us take an example here. So the current flowing in this direction. So the magnetic field is around the wire is the perpendicular to the direction of the current flow. So the magnetic field is the perpendicular to the direction of the current flow. The current flowing in this direction. Suppose this is a wire. So this is a electrical wire. So the charges are moving with a constant velocity. So here this is the magnetic field. So this is the magnetic field. So the magnetic field is perpendicular to the direction of the current flow. So direction of the current flow. So the magnetic field is perpendicular to the direction of the current is flowing. So direction of the current so magnetic field is perpendicular to the direction of the current flow. So here I'm taking an example. Suppose these two charges are moving with a constant velocity means it produces the magnetic field. Suppose the two charges are rest, so they are not moving. The two charges are not moving. Nothing but here only electric field is produces. So here the magnetic force is always perpendicular to the direction of the motion of the flow. So the magnetic field. So we can denote it as a B. So we can denote it as a B. So units of the magnetic field is Tesla. Units of the magnetic field is Tesla. So here it is the magnetic field depends upon the some factors. So in that one, suppose the charge is flowing through this wire, nothing but, so whenever the charge is moving, charge is having a constant velocity, so it produces the magnetic field. So nothing but it depends upon the charge. So nothing but the magnetic field is depends upon the charge and velocity of the, and also velocity, right? So velocity of the charge. So charge is depend upon the magnetic field depend upon the charge and velocity. So we can write as a B diagonal proportional to Q into V. And also suppose here I am taking one example here. So this is the charge Q. So I am taking the around the charge, so magnetic field is there, right? So here I am taking the point P on the certain magnetic field. So I am taking point P. So the distance between these two is R. So the charge is moving with the velocity V. So the angle between these two is theta, charge and this line. So the angle between the charge and from the point P is theta. So whenever I'm changing the angle means I'm changing the magnetic field. So the magnetic field depends upon the angle also. So here V cross R nothing but so sin theta. So ఇక్కడ మనం ఏమైనా so angle depends upon the so the magnetic field depends upon the angle means sin theta. Here I'm taking the sin theta angle. So y means, so here the angle theta. So whenever the angle 0 degrees, so it is a minimum magnetic effects. Okay, whenever the sin 0 is nothing but 0. So whenever the angle between these two is 90 degrees, so you get the maximum magnetic effect. So that's why we are using the sin theta. So combine this, so we can write as a, so magnetic field is B directly proportional to, so QV sin theta by R square. So and also magnetic field is depends upon the, so inversely proportional to R square. We can write as a magnetic field B is directly proportional to QV and indirectly proportional, so inversely proportional to R square. We can write as a QV sin theta by R square. So after removing proportionality, we get the B is equal to, so proportional limit mu naught by 4 pi QV sin theta by R square. QV sin theta by R square. So this is the formula for the magnetic field due to the moving charge. So this is the formula for the, so magnetic field due to moving charge. Magnetic field due to moving charge. This is formula for the magnetic field due to moving charge. So this is about the magnetic field due to moving charge. Now how the magnetic field is produced in the moving charge. So this is about the magnetic effects of the current. So thank you. Thank you for watching. So ఇంకా నెక్స్ట్ వీడియోస్ అప్లోడ్ చేస్తాం, రెగ్యులర్ వాచ్ చేస్తుండండి. థ్యాంక్ యూ.